Today, let's finish up that hash table we were working on last week, the more general one. Specifically, today we want to clean up our memory. Welcome back, everybody. Last week, we started working on a hash table data structure. It's my second video on hash tables. And this one, we were really trying to make it more general. We were trying to create a hash table where we could store a bunch of different data types in the table. And so we could change out hash functions, which we did. But I ran out of time last time. And specifically, we didn't get a chance to fix all of our memory leaks. And so today, that's what I want to do. If you missed the last video, check that out. I'll link down in the description. Also, you can get the source code for this video and all my videos on Patreon. Thank you for supporting this channel. Now let's jump into the code. Okay, so this is where we left off last time. We got a bunch of code here, so if you're feeling like you just got dumped into something out of the blue, by all means check out the previous video, it'll catch you up. But where we left off last time is we were running this test program and it seemed to work okay, except when we ran it through Valgrind, we did notice that we had a whole bunch of leaked memory, and that's because I didn't get around to freeing all the elements. So we want to do that today. Also, one more thing before I forget. One of the great things about splitting this across 2 weeks is I got lots of comments. And one of those that I thought I definitely wanted to point out is down here. So several places in this example, I would malloc space for a string and I would copy it. Now, usually in classrooms or when I'm teaching, I like to do this explicitly so that people who are new to this basically can see the individual steps that I'm going through. But several of you pointed out, and it's a very good point, that there is a function that does this together because this is a really common thing that you do in programs. You know, you want to make a copy of a string, so you got to allocate space for it and then you copy it. And so often when there's something that's really common, we get a special function for it. And so in this case, it is string dupe. So this code right here can be replaced just by saying the key for this element is equal to str dupe key, right? So this basically does exactly what we were doing before, but it is more compact. And who knows, maybe it's even more efficient. So yeah, so I just wanted to point that out. Thank you so much for the comments. It's great to get feedback and to be able to show you different options. So yeah, definitely thank you for that. The other thing that a bunch of people pointed out, which is a very good point, is that in my haste, so I type defed my hash table here, but then I type defed it again over here, right? And that's totally unnecessary and can result in confusion, all sorts of issues. So, you know, let's just type def it once. So I can remove this here. And now let's get down to why we're actually here looking at cleaning up these memory leaks. Okay, so let's just make sure we didn't break anything. Okay, it looks okay. So now let's look at how we actually clean stuff up. Now the problem was down here in our hash table destroy. I left this comment here so I would come back. Often one thing actually that I probably should have done is you typically want to have some kind of marker in your comments. If you have a comment that's basically telling you I've got unfinished business here, I often try to put something like to do in here. I didn't in the last video just because I was in a hurry, but having something that you always put in there is really good because then you can search for it. But anyway, let's actually do something about this and let's come in here and say, let's clean up our individual elements. So one way that we could approach this is we could just do something simple like this. We just run through the table and say, you know, UN32TI, we're gonna just run through from 0 to the length of our hash table, the number of elements in the hash table. And then remember that each of our elements is actually a linked list, right? So we're gonna have to go through and free the list. And I'm just gonna say, while the ith element is not null, then what I'm gonna do is say, let's say entry, let's make a temporary pointer and set that equal to the head of the linked list. Looks like I forgot an S right here. And then we are just going to remove the head. So we'll do something like this. Ith element is equal to ht elements of I arrow next. Okay, so we're just moving the pointer down 1. So then we can come in here and free the, so in this temp object, this temp element, we're just going to free the key first. We know we can do that because it's just a string and we created it. And then for now, let's just come in here and say free that temporary element. Let's just come in here and make sure that we didn't break anything. And if we run this through Valgrind again, well, you can see we still do have some leaked memory. And the reason for that is that I freed the key and I freed the element, but I didn't free the object that it's pointing to. So that's still getting lost in there. This is a really common issue when you're dealing with objects that have pointers to other objects, is sometimes you forget that you've got a member that needs to get freed. But then we can also come in here and say free the object. Okay, now we should be able to see that disappear, hopefully, and we do. Okay, so at this point, we know that all of our blocks are freed. Now, this is going to work if the cleanup that we want to do on an object when we destroy it is strictly to free it. But in some cases, that may not be what we want to do. Let's say that this object here, let's say that this was not just a simple block of memory allocated on the heap. Maybe it's a linked list or a binary tree or something more complicated that would actually require a more involved cleanup, okay? So in this case, I actually want to make this more general. Because hey, that's the point of this. This exercise was to try to make a very general hash table. So what I want to do is let's go back up here and let's in our effort to make this more general, let's type def another kind of function pointer. So this one's not going to return anything. We're going to call this cleanup function. And what we're going to do is just simply pass in a void pointer. And so what this is going to do, this is going to allow the user to specify if they want a cleanup function other than free. We can still have free be the default, but this at least gives flexibility if I want to do something more complicated. Okay, so if we come down here, now in our hash table create, let's also allow you to pass in a cleanup function pointer, call it CF. So that's just going to give us the option to specify the function that we want to clean things up with. And I think that's the only thing that changes here. Now we jump over here. Let's look at, well, first of all, our hash table now needs a cleanup function, pointer. Okay, so we've got cleanup here. And then if we come down to hash table create, same thing here, cleanup function, pointer, CF. And now in this function, let's store this. So we could just say ht cleanup equals CF. I'm actually going to go one step further because I want to give you the opportunity to just use free if you don't want to specify your own functions. So we could say like you pass in null cleanup function for default freeing behavior. So if we want to do that, and of course we could have a default for the hash function as well, which I didn't do, but we could do that. But let's say we want to pass in a null cleanup function as the default, then what I can do here is just check and say, okay, so if CF, then we're going to set the cleanup function to be CF. Otherwise, we're going to say ht cleanup equals free. Because you notice that I made my cleanup function look exactly like free. It takes a void pointer. It doesn't return anything. So this allows me to basically say, hey, if they didn't specify a cleanup function, rather than having to have an if statement down in destroy, just specify free as the cleanup function that we will use by default. Okay, so now that we have this, we can go down to destroy here. And instead of calling free, we're just going to say ht cleanup on our object. And so this will use the cleanup function that the user provided if they provided one. Otherwise, it will use free. And so that should work. Let's take a quick look, make sure I didn't break. Oh, I did break something. Oh yeah, I forgot to update my test. Sorry, when you change your interface, you got to update your tests. So if we come down here and we say, first of all, we can just say null, just say I don't want to specify a cleanup function. And so now just make sure we didn't introduce any new memory leaks. We shouldn't have, but let's just verify. Okay, great, so that worked. But now imagine that I wanted to come in here and make my own cleanup function, void my cleanup. And so let's say that I wanted to do, well, in this case, I could say destroying, let's say I want to print something out, which this is going to get probably annoyingly verbose, but just for demonstration purposes. So if I do this, and let's do this with the short word list so it's not so ridiculously messy. So then what we would do is come down here and we could specify my cleanup right here, compile it. And if we run it, then we should see, so we should see a bunch of output. And of course, this was just to demonstrate that it is actually calling my function now. In your programs, you'll of course do something much more sensible, like free the more complicated data structure that was stored in the hash table. But for now, I think this is where I'm gonna stop for today. We have succeeded in cleaning up our memory leaks. So now we have a more workable data structure that's not going to just consume all of your memory. So that's a victory. I do plan to follow this up with one more video. I want to look at the impact of hash functions. Because in this example, and some of you have given me a hard time about this in the past, I just threw in some random hash function that I just made myself. But in reality, there are a lot of different options for hash functions. and some are going to give you better results than others. So if you've ever wondered how much of a difference the hash function in this hash table actually makes, well, we'll take a look at that in a future video, probably next week. So I hope that was helpful. I hope this rounds out your hash table experience today. Hope you learned something new. If not, I hope it was a useful refresher or that you just enjoyed hearing the sound of my voice. If you're liking this content, be sure to drop me a like, subscribe to the channel, tell a friend, help me get the word out, and until next time, I'll see you later.